Today I want to talk about the angles formed by parallel lines and transversals.
Today we're gonna make parallel lines in the sand and find the angles created by those parallel lines. Let's go ahead, check them out. Alright folks, so what do we get here? Well, we got two parallel lines and now we're gonna cross them by a transversal. This big boy is my transversal. Check out how it crosses my two parallel lines. Here are my two parallel
Here's my transversal and watch how it crosses my two parallel lines.
Now let's add in some more. And now for the grand finale. Watch as the transversal crosses these three parallel lines, and now we're gonna knock them over. 3, 2, 1, and we're done.
Right folks, welcome to your big idea. Let's check out some examples of parallel lines and transversals. So in this example, we have to find out the measure of angle x, or we have to find out what x is equal to. So how do we do that? Well, you got to use your knowledge about transversals, parallel lines, angles, all of that. So first thing we're going to ask ourselves is, we got two angles here, this one and this one. What type of angles are they? Are they alternate interior, alternate exterior, same side interior, same side exterior, corresponding angles? What are they? Here's how we can answer that question. First, we're going to start off with a basic. Okay, are these angles interior or are they exterior angles? Okay, that's the first question I'm going to ask you. Now, how do you answer a question like that? Well, just look. First thing you're going to do, interior angles are inside the parallel lines and exterior angles are on the outside, right? And that's pretty much it. Now, you can see that one of the angles is on the interior, and that's this one, and one of them is on the exterior, and that's this one. So it's like one is on the outside, one is on the inside. So, I mean, the correct answer would actually be checking both. So that doesn't really help us, does it? Okay, then you might think, hey, I noticed that these two angles look like they're kind of in the same spot, if you know what I mean. They're just shifted a little bit. Do you see what I mean? It's kind of like if I take this little angle here, if I take that little angle and I transport it here, it basically looks the same. And actually it is. It's so same, we can set them equal to each other because they're corresponding angles and they're congruent. So x is equal to, let's see, 40 minus 10, that would give us 30 degrees. And that's it. That's how you solve one of these problems. Welcome to the second problem of our big idea. For this problem, we got to find out the measure of a very specific angle. And that's this red angle that I've shaded in right here. We got to find out the measure of that angle. Alright, so how are we going to do it? First thing we got to do is ask ourselves, what information do we have? We got two angles and some parallel lines. Let's get to business. So first question I'm going to ask myself is, what kind of angles are these? Are they interior angles or are they exterior angles? Remember, exterior means outside the parallel lines, interior means inside. So let's write that question down. Are these two angles on the interior or are they on the exterior? Well, look where they are, and you'll notice that both of them follow in the yellow region, in the light yellow region. So both of these angles are actually in the interior, and they're in the interior of the parallel lines. Like that helps us at all? It does. Not only are they in the interior, but they're both on the same side of the transversal, right? Both of them, I don't know if you realize this, but both of them are on this side of the transversal. That means they're same side interior angles. You know what that means? They add up to 180. So we can add them up, and they equal 180. So 6x minus 7 plus 7x minus 5 plus 5, and we're going to set that to 180. Just solve for x. So 13x minus 2 is 180. 13x is equal to 182. X is equal to 54 perhaps. Let's see if I can get my math right. And of course I got that wrong. So let's try that again. So 180 divided by 13. What's that going to be? Looks like 14. Alright, good. So x is 14. But we want to know what this red angle is. How do we find that out? How do we find out what the measure of this red angle is? Well, the measure of that red angle would be equal to the measure of this angle, right? Because those are alternate interior. So if we just find out the measure of 7x plus 5, we can find out the measure of this. So let's do it. 7x plus 5 is just substitute in 14 for x, and you can find out what this angle is. So 14 times 7, let's see, that's going to give me 98. So this is 98 plus 5 degrees, and that's 103 degrees. And that, ladies and gentlemen, is the measure of the angle we wanted, 103 degrees. And we're done. Now, let's check out the big idea. Folks, let's check out our big idea. In the accompanying diagram, our ray AD is parallel to BC. Here's ray AD, here's ray BC, and they're parallel. Now, AC bisects BAD. So we got this ray AC, is shown in green, and what it does, it bisects our angle, and our angle is BAD. So here's what's happening. If the measure of angle ABC is 1, that's right here, what is the measure of angle 1 in terms of x? Okay, and the other part of our big idea is this question. If in the accompanying diagram, line 1 and line 2 are parallel, line 3 and line 4 are parallel, then angle x is not always congruent to which angle? Good luck and have fun.